Okay, let's dive right into this. So, picture this scenario. Your code is running absolutely perfectly on your laptop. You push it to a teammate or maybe deploy it to a server, and suddenly it completely breaks. It's the exact same code, but a totally different result. Nobody touched the logic, so, what actually changed? Well, welcome to this explainer. Today, we're going to demystify a tool that pretty much quietly ended that entire mystery. It's called Docker. And by the end of our time together, I promise you won't just understand the concepts, you're gonna have a practical tutorial to actually ship your very first container.
Here is our roadmap for today. First, we'll cover the My Machine problem. Then, the shipping container solution. Third is blueprints and running instances. Fourth, building your first Dockerfile. And we'll wrap up with your first container challenge.
All right, kicking things off with section 1, the My Machine problem.
Let's start with a structural issue that you have absolutely faced. Ah, yes. It works on my machine. Literally the 6 scariest words in software development. Pretty much every developer hits this wall eventually. It's this dreaded mystery that has cost teams around the world millions of hours, literally millions, in lost productivity and just absolute debugging nightmares. Because, you see, this isn't just bad luck. It happens because of specific, hidden conflicts. Like, maybe your machine is running node version 20, but the production server is still stuck on version 16, so your code quietly breaks. Or maybe you installed a library globally months ago and totally forgot about it. Your new teammate hasn't installed it, so the app just crashes for them. And don't even get me started on setting up a project on a new laptop. That can eat up an entire afternoon of installing the right versions of everything in the exact right order. Basically, your code assumes an environment that only exists inside your head and on your specific machine. That is a massive structural problem.
Moving right along to section 2, the shipping container solution.
What's really interesting here is that the tech industry actually didn't invent the solution to this problem. We flat out borrowed it from the physical world. Think about the history of shipping. Before the 1950s, shipping physical goods around the world was absolute chaos. A crate of bananas, a barrel of oil, a stack of furniture, they all needed different handling, different trucks, and totally different loading crews. It was slow, it was expensive, and stuff got damaged all the time. But then, in 1956, someone had this beautifully simple idea. What if everything shipped in an identical steel box? Any crane could lift it, any ship could stack it. It literally didn't matter what was inside. The box was always handled the exact same way. It standardized how things traveled, not what was shipped. Well, Docker does the exact same thing for your software. Instead of shipping code and just crossing your fingers that the destination has the right setup, Docker packages your app into one standardized box.
Now, before Docker came along, the best way to get that kind of isolation was using virtual machines. But VMs are incredibly heavy. Every single VM requires its own full operating system, which means they're slow to start up and they just chew through your system's resources. Docker containers, on the flip side, actually share the host machine's operating system kernel. So they give you that exact same isolation, but they start in seconds and are incredibly lightweight. Suddenly, it works on my machine becomes it works everywhere, because everywhere is now running the exact same box.
Okay, section 3, blueprints and running instances. To actually use this tech, we really need to clear up 2 core terms that people constantly mix up. First up is the image. You can think of an image as a snapshot, or a blueprint of your application and absolutely everything it needs to run. The really crucial point to remember here is that an image doesn't run by itself. It is simply the immutable recipe. And second is the container. A container is the actual running instance of that image. So if the image is a cookie cutter, the containers are the cookies. One single image can stamp out dozens of identical containers that all run uniformly, keeping their files, libraries, and settings totally isolated. Let's quickly talk about how the pros handle this. When we look at best practices, you definitely want to use small official base images like Node 20 Alpine just to keep things lightweight. You should absolutely be using a .dockerignore file to keep bloated folders like node modules out of your image. Always tag your images meaningfully with version numbers, and please, keep your API keys and passwords out of your Dockerfile. Now for common mistakes to avoid, don't treat a container like a virtual machine. Don't go cramming a database, a web server, and a background worker all into one container. Generally speaking, one container should do one job. Also, never forget that any changes made inside a running container just disappear once that container is removed. If you want to keep that data, you have to use volumes.
All right, section 4, building your first Dockerfile.
Okay, enough theory. Let's actually get into the tutorial part of this explainer. The big takeaway here is understanding this high-level workflow of how code actually becomes a running, shareable container. Step 1. You write a plain text Dockerfile recipe. Step 2. You run the Docker build command to turn that recipe into your blueprint image. Step 3. You use Docker run to stamp out a living container. And Step 4. You share it with the world via Docker Hub.
So let's look at step 1 in action. Imagine we have a little Node.js API. This right here is what a minimal Dockerfile looks like. We start with from node 20 Alpine, that sets our base environment. Then work directory app sets up our isolated directory. Next, we copy our package files and run npm install so we get our dependencies exactly right. Then we copy the rest of our code in and expose port 3000 so we can actually talk to it. And finally, the CMD tells the container how to wake up and start running, which in this case is node server.js. Boom, that is your recipe. From there, we just jump over to the terminal, you run a single command, docker build -t myapi. This tells Docker to read that recipe we just wrote, gather up the node version, the dependencies, and your code, and build the stamped blueprint image. That -t myapi part, that just gives it a nice readable name or tag.
And now for the magic moment. You type docker run -p3000/3000 myapi. When you hit enter, the Docker engine creates an entirely isolated space with its own file system and network. The P just maps the port from the container to your actual local machine. And just like that, your API is officially up and running exactly as it was on your machine, but now it's wrapped securely in that identical steel box.
Let's bring it all together in section 5, your first container challenge.
To really lock this in, here is your tutorial guide to completing a practical challenge. Step 1. Go ahead and install Docker Desktop on your machine. Step 2. Open your terminal and type docker run hello world. That's a tiny test container that will print out a success message and explain exactly what Docker just did behind the scenes. Step 3. Pick a small script you've written in the past and write a simple Docker file for it, just like the recipe we just reviewed. And Step 4. Run the build and run commands. Confirm your app behaves identically inside the container as it does natively. I highly challenge you to pause this explainer and go do this right now. Once you knock out these steps, you have officially conquered environment inconsistency.
Because once you do, you hold the power to package any application into a standardized, portable unit that is literally guaranteed to run the exact same way on your laptop, your teammate's laptop, or a production server halfway across the world. The "it works on my machine" excuse? Yeah, that's officially retired. So now that your code can run flawlessly anywhere, what are you going to build next?